On September 9, 1947, a moth stopped human progress. Not metaphorically, literally, a real moth. It flew into a computer the size of a gymnasium. An engineer taped it to the logbook, filed it, moved on. That entry read, "First actual case of bug being found." That word, bug, is now used 4 billion times a day. Before software existed, computation was a job title. Human beings were the computers. They sat in rows. They did arithmetic. All day, every day. They were called computers. Not machines. People, mostly women, paid less than their male colleagues for doing the same calculations faster. When machines finally arrived, programming them meant physically punching holes into cards. Drop the stack, lose your entire program. Start over. The ENIAC computer had 6,000 switches. Programming it meant setting each one by hand. There was no screen, no keyboard, no undo button. If something went wrong, engineers physically traced thousands of cables by hand. Debugging meant crawling inside the machine, sometimes for days. In 1843, Ada Lovelace wrote the first algorithm. For a machine that didn't exist yet, she described loops, conditionals, and variables. A century before anyone built them, Charles Babbage designed the machine. He never finished it. He ran out of money, then patience, then funding. The British government called it a waste. Grace Hopper changed everything. She believed computers should understand human language. Her colleagues laughed. She built the first compiler, anyway. A compiler translates human language into machine code. In 1952, this was considered theoretically impossible. Hopper demonstrated it worked. The response from her peers: polite disbelief. IBM's first commercial computers cost more than a house. Companies leased them by the hour. A single calculation run could cost thousands of dollars. Errors were not tolerated. Programmers submitted code through a window, like a bank teller. They handed over their punch cards, waited hours, received a single printed error message in return. One missing semicolon. One wrong punch. The entire job failed. They fixed it, resubmitted, waited again. This was considered normal. The first programmers had no textbooks, no Stack Overflow, no tutorials. They wrote the manuals themselves. While simultaneously figuring out what they were doing, Alan Turing defined what a computer could theoretically do in 1936. On paper, with no machine in front of him. Pure logic, pure abstraction, decades ahead of reality. During World War II, Turing's team broke the Nazi Enigma code. Historians estimate this shortened the war by 2 years. The British government's reward: they chemically castrated him in 1952. His crime: being gay. The man who invented theoretical computer science was destroyed by the institution he saved. He died the following year, cause officially listed as suicide. At NASA, rooms full of black women performed trajectory calculations by hand. Katherine Johnson's math sent humans to the moon. Her name appeared on no official documentation for decades. The Apollo guidance computer had less processing power than a modern digital wristwatch. The software that ran it was hand-stitched into memory. Literally, women wove copper wire through magnetic cores by hand. This was called LOL memory by engineers. Little old lady memory, because the technique resembled needlework. It was also completely irreversible. One mistake meant starting the entire module over. In 1975, software was still considered worthless. Hardware companies gave it away free with machines. Bill Gates wrote a letter calling this theft. The industry called him absurd. Within a decade, software became the most valuable product in human history. Then came the question of who would control it. In the 1970s and 80s, operating systems were not products. They were battlegrounds. Gary Kildall wrote CP/M, the first widely used personal computer operating system. IBM came to license it. Kildall was not available that day. Exactly why remains disputed. IBM went to Bill Gates instead. Gates did not have an operating system. He bought one for $75,000 from a programmer named Tim Patterson. Patterson had built it in 4 months. Gates sold it to IBM for millions. Kildall spent the rest of his life watching his work rebranded, resold, and forgotten. He died in 1994. The official cause was blunt head trauma. He was 52. The industry moved on without acknowledgement. It usually does. The personal computer arrived in living rooms in the 1980s. Nobody knew what to do with it. Early marketing suggested using it to store recipes and balance checkbooks. Software was sold in boxes. Physical boxes, with printed manuals hundreds of pages long. If the program crashed, you called a telephone hotline and waited on hold for hours. The computing power that once filled an entire building now fits inside a rectangle in your pocket. That rectangle runs on principles first described by a mathematician who never owned a computer. The internet began as a military project. ARPANET's first message in 1969 was LO. The intended message was login. The system crashed after 2 letters. Humanity's first internet communication was an accident. The network was designed to survive nuclear war. It was so decentralized that no single bomb could destroy it. Today, that same network is primarily used to watch videos of cats. Turing asked whether machines could think. Lovelace asked what machines could create. Hopper asked whether humans and machines could speak the same language. None of them asked whether we would use all of this to argue with strangers. From Lovelace's algorithm to your phone took 180 years. Thousands of people gave their careers, their freedom, and in some cases their lives to build the tools you use to avoid eye contact on public transport. The people who built software engineering were mathematicians, linguists, and military codebreakers. They were underpaid, uncredited, and frequently institutionally destroyed. We remember almost none of them by name. Today's software engineers inherit a discipline built on foundations they were never taught. Every loop, every compiler, every click traces back to a room full of people doing arithmetic by hand under fluorescent lights for poverty wages. The industry calls itself innovative. It is. It just didn't start that way.